Hi class, in this video I'm just going to go through the electrical conducting system of the heart. I also go through it in the PowerPoint recording, but just to go into it in a little bit more detail, okay? So here's my drawing of the heart here, my very basic drawing. This layer here is the myocardium, okay? So this is a muscle layer surrounding the heart, including here, etc. Okay, so this is the muscle layer surrounding the heart in purple. Okay, so let's draw this in red here. So we start in the right atrium, okay, in this little area here. This is known as the sinoatrial node, or SA node. Okay, sinoatrial node. Okay, so this is known as the pacemaker of the heart. Okay, so these are the nodal cells that I talk about in the PowerPoint recording when I talk about heart muscle contraction. Okay, so SA node. So this depolarizes on its own about 90 to 100 times per minute. So it generates new electrical impulses that stimulate the myocardial cells to contract. Okay, but we don't have 90 to 100 beats per minute, right? It's a bit less than that. So we have our vagus nerve, which is part of our parasympathetic system, which that's our rest and digest system, right? So that vagus nerve can help slow the heart rate down because we don't need it to pump that fast. The endocrine system can also slow the heart rate down, but it takes some time, right? The endocrine system is a bit of a slower system than the nervous system. Okay, so we have things like natriuretic peptides, angiotensin. Those things can slow down the heart rate. Okay, all right, so this SA node is then going to send electrical impulses to the left atrium. And of course, there are branches everywhere. So it's branching off in all different directions, okay, to electrically stimulate those muscle cells, okay. Then that's next sent to the AV node. Okay, so the AV, atrioventricular, it's right between the atria and the ventricles. Okay, so the AV node. Okay, here it's going to pause. Okay, so the AV node is also electrically active, but spontaneous depolarization rate is lower than that of the SA node. Okay, so this is like a collecting node. It collects from the atria. Okay, so like I said, there's a delay here, about 40 milliseconds, not a very long delay, right? But there is a delay, and that's so that the heart has time for blood to get from the atria down into the ventricles. Okay, so it's kind of electrically insulated between the atria and the ventricles, so it just stops here for a minute. Sorry, I don't know where my... Okay. All right. Then after that pause, we pass down to the bundle of His, also known as the AV bundle. So it's right here. We're going to call it bundle of His. Okay, that branches off into right and left bundle branches. So we'll just say bundle branches. Okay, so again, anatomical right and anatomical left bundle branches. And there's branching off of these as well to electrically stimulate all of the muscle in the heart. Okay. And then that goes down to the apex and then up here to the right and to the left, with branching off through out, and those are known as the Purkinje fibers. Okay, Purkinje. Okay. All right, so, and just another note here, over here, this is the interventricular septum, so that's where you're going to find from the AV node that electrical impulse is passed down through this interventricular septum. Okay, so these electrical impulses are sent down and around, right? So the ventricles are squeezing in this way, right? And also up this way to squeeze all the blood through either the pulmonary artery from the right ventricle or the aorta here from the left ventricle. Okay, so they want to try to squeeze as much of that blood out as we can. Okay. So that is really it. Oh, I just wanted to expand on that electrically insulated area here. Okay. So it's known as the atrioventricular ring because it's between the atria and the ventricles. So it's where I'm drawing here, here. So that's the atrioventricular ring. Okay, so it's resistant to electrical impulses because it's mostly made out of collagen. Remember I talked about in my PowerPoint video that these are made of collagen here. Okay, so that's why that impulse stops at the AV node, because it's right in this area. Okay, then when we get to the interventricular septum, then the impulse can just keep passing along through the left and right bundle branches and the Purkinje fibers.